this concept of generalist, or the ability to integrate art, science and humanities, is key to everything that we do within the Cynefin Centre, within Cognitive Edge. And it means that you need people who are doing the R&D to have a very curious sort of attitude, it's not sort of, I don't understand this, but I think I could do something with it, is where you're going. And one of the most fertile sources for this, which I've been going to for years now, is a festival at Hay-on-Wye called How the Light Gets In, which runs parallel with the book festivals. And you get scientists and philosophers and politicians and artists all in conversation with each other and lectures and with the audience. Now, one of the most interesting things I came across about 5 years ago was a thing called constructor theory in physics. This has come from Deutsche in Cambridge, and it's the first attempt to look at physics, not in terms of explaining the physical universe by finding the lowest possible particle. And my gut feel is we went far enough with quarks. I quite like quarks, but after that it gets difficult. Yeah. Instead, what people are trying to do is to look at the system as a whole. And so the way constructor theory works is you start off by defining a counterfactual universe. So you start off not by saying what do we want to happen or what is the lowest particle. You start off by saying what is impossible, what can't happen. So we can't break the laws of gravity if we're on the Earth, and so on. So those are examples. Yeah? And having defined the counterfactual space, then within the space itself, we look at what are called constructors. This is an idea which actually comes before constructor theory, but it's being picked up. And this isn't the same as constructional law. That's completely different. That comes out of thermodynamics, not quantum mechanics. So we look at constructors, and constructors produce repeatable outcomes. This, by the way, is fascinating because it gets rid of things like quantum uncertainty. So a machine is one example of a constructor. You set up a machine, you design it, it produces consistent outcome as long as it's got the right inputs. Another example, which is more human-based, is the way we use ritual. For example, the ritualization of donning a uniform or going through scrubbing up, which actually changes the cognitive activation patterns of people so they see the world in a different way. So we use ritual in the armed services, we use ritual in operating systems as hospitals to actually trigger consistent, regular outcome. So a constructor is anything which allows you to create effectively a replicable outcome, or without so much variation, you've got some assessment of where it will happen. And the other key element of this, there's a lot more to constructor theory than this, but the other one I want to isolate is that whatever has the lowest energy gradient will win. And this is generally true of all evolutionary history. Minimization of energy is kind of like a key focus. So this actually gives us something fascinating. We map the counterfactual space, we mount the constructors that we know about. We identify the energy gradients, which is something we can do with SenseMaker, and we can look at energy gradients from different perspectives, employees, managers, customers, for example. And we can identify what has the lowest energy gradient, what is the easiest thing for people to do. So if you want people to be virtuous and the energy cost of sin is less, then assume they're going to sin. It's kind of like a basic principle on this. So I've taken that, working with John at Austin University and others, and then added to that the work we've done on constraint mapping or constraint typologies and scaffolding typologies. So constraints are really important to understanding complexity theory. And people tend to think of constraints in the terms of Goldratt's theory of constraints as something you remove to improve flow. But actually in evolutionary biology, what are called enabling constraints are critical for evolution. Yeah? If you have a system without constraints, then all possibilities are equiprobable. It's only when you introduce constraints that certain pathways become more probable and you can get some type of progress. So in Cynefin, we've defined fixed constraints, rigid constraints, enabling constraints, the absence of constraints, as ways of understanding it. And just to expand on that a bit, one of the things I often say is something which is ordered is contained, whereas something which is complex is connected. Now, containers and connections are both types of constraint. They both provide limitations. But the boundaries of a system which is connected are radically different from the boundaries of a system which is contained, to take one example. So we have a whole typology of constraints. We talk about constraints which are resilient as opposed to constraints which are robust. And the metaphor for that is the difference between a salt marsh and a seawall. So a seawall is robust, it's fixed, it's rigid, it's reliable, it keeps the sea out. We can drain the land on the landward side, we can use it for agriculture. And it's all fine, it's very robust until the day the dam breaks. The design conditions are exceeded, at which point we get mass inundation. So one of the characteristics of robust systems is they're brilliant until they break and then you wish they weren't there. Resilience, on the other hand, is a salt marsh. So if a salt marsh basically fills up, it's not as efficient as a seawall, but it can take a huge amount of seawater in. It's constantly changing and shifting to accommodate different channels. And critically, once it's saturated, it may overspill, but it doesn't do this catastrophic release. So a salt marsh is resilient, and I define resilience as continuity of identity over time. It's survival by change, not by rigidity. And by the way, for me, that includes Taleb's concept of anti-fragile, which I see as a subset of resilience. And I think I'm more in conformity with the literature on that. So that's one type of constraint. We talk about elastic constraints, which is like an elastic band. So they stretch for a bit, but when they break again, it's catastrophic. You can talk about tethers, which is like a climbing rope, so they only snap in when they're needed. We can talk about things like British constitutional law, which actually goes through step changes. If you look at the history of obscenity trials in Britain, it's fascinating to see how things which would have been deemed obscene in the 19th century are not even brought to trial in the 21st century. And the reason is that the legal system can make changes through case law over time. So that's another type of resilience. And then we have this key concept I developed called dark constraints, which is you can see something is having an impact, but we don't know what is having the impact. Now, one of the reasons I've always used constraint mapping is with a C-level audience, it's you don't want them to talk about what's happening or where they want to go. Because one of the key things about human beings is we only ever assess a situation based on how we've decided to act. So if you want to increase objectivity into decision making, you want to get people to look at something indirectly, not directly. So we start with constraint mapping, which we can do through SenseMaker over large populations and present it, or we can do it in workshops. And people identify the constraints they're aware of, the types of constraints, what they could do with those constraints. And then their interventions, if it's complex, are to change constraints and see what happens rather than determine outcome. So that's been powerful. And then over a couple of years, we worked with a whole body of academics to create a complexity-based approach to design thinking. And one of the key components in that was to look at the concept of scaffolding. So again, we've got a typology of scaffolding. So you can have an endoskeleton or an exoskeleton. So insects have an exoskeleton. It's a container, coming back to that concept, which means there's a limit to how big an insect can grow before gravity collapses it. And you don't get much variety between insects. Human beings have an endoskeleton. It provides structural coherence, that coherence word again, but you get a huge amount of variety which forms around the basically spine and the skeletal structure and everything else. So that's one way of looking at it. You've got scaffolding which you put up to create buildings. So that's scaffolding that you intend to take away. And you can have iron scaffolding, or you can have the bamboo scaffolding you find in Hong Kong. That's more flexible, but there's more training. In medical work, we have nutrient lattices that you place over burns, which provide a scaffolding for the skin to regrow, but the nutrients dissolve over time. Or we've got microcardial lace, which actually sinks into the heart and places microfilaments for electrical regeneration. So there's some very sophisticated stuff. And then we have, again, this sort of dark scaffolding concept. So if you look at extreme sports, this is Anne Pendleton-Julian's work, it takes a decade or so for the scaffolding to emerge over time to support an extreme sport, because you've got to have technology developments, practice developments, training developments. You can't do it overnight. So scaffolding and constraints are things that we can manage in a complex system. So coming back to constructor theory, we use constraint mapping to identify what the current counterfactual universe is, and we also identify what constraints could be changed at what cost over what time, which allows us to identify how we could change that counterfactual universe if we wanted to. And then we identify existing constructors, and actually scaffolding, for example, is a type of constructor. It creates a degree of limitation. We identify the constructors in play, and we identify spaces where we want constructors, which we then put in place and develop experimentally. Now, this is a radical new approach to strategy. Yeah, it's structured, it's disciplined, it's rigorous, it's based on natural science, it's based on things that we can manage. But it also, and this is still under development, gives executives a language by which they can make sense of uncertainty.